Note card 12 is y-axis symmetry and even functions. It says y-axis symmetry is a mirror image of the curve on the left side of the y-axis exists on the right side of the curve. So if this is my y-axis here, if the left side is a mirror image of the right side, then I have y-axis symmetry or even symmetry. Okay? It says the even functions have y-axis symmetry. So it says here to determine if a function is an even function, we have to look at the graph. And if we have y-axis symmetry, which we've already determined here that we do, then we have an even function. That part's pretty easy. This next part is easy, but it's not as easy as the previous part. Or I hope that as easy as the previous part was. If we look here, we want to be able to determine basically algebraically if a function is even. So it says that a function is even provided that f of x is equal to f of negative x. Okay? So what we want to do to be able to do this, this can look confusing right here, but I promise you it's not. All you have to do is change the x values to negative x in the equation. Once you simplify that, if the new equation equals the original equation, then y-axis symmetry exists, therefore we would have an even function. Let me show you what I'm talking about. On example 1, we have f of x is equal to x squared minus 1. To determine if it's an even function, what I want to do is basically replace every x with a negative x. So just like before when I was evaluating functions, I would rewrite my function using a set of parentheses everywhere I have an x, and then I want to, inside this parenthesis, place this negative x. And then simplify. Well, negative x squared is just x squared, because when I take a negative number and square it, it's just that number positive. So negative x squared is positive x squared. So then minus 1, and what I have is that what I have at the end matches the original, therefore I have y-axis symmetry, and it is an even function. Looking at example 2, I have f of x is equal to x to the third plus 1. And so again, I want to replace x with a negative x. So I rewrite the function using a set of parentheses for x. And now I'll replace that with a negative x. Well, negative x to the third is still negative x to the third, because if I have negative x to the third, that means negative x times negative x times negative x. Well, negative x times negative x is positive x, and then times that negative x, so x times negative x is negative x. The short rule for this is when you take a negative number and raise it to an odd power, your answer will be negative. However, if you go back to the previous example, if you take a negative number and raise it to an even power, then your answer will be positive. Okay, now let's talk about creating graphs. Well, before we do that, since we have a negative x to the third, this does not have y-axis symmetry. So it's not even. On this next part, I don't think I'll be doing an example with you. There are going to be some homework problems over this. To create a graph of an even function given some points, all you have to do is follow these steps. Maybe I'll try to create some kind of an example. A, change the x values of the points to negative x. Then next, B, keep the y values the same. And then finally, C, graph all of the points and connect them to create a function with y-axis symmetry. So we're going to be creating a graph of an even function given some points. So let's see if I can make a graph here. And this will not be exact because my graph isn't going to be exact. So let's say if I was given some points, let's say I have some xy values. Maybe I have 1, 2, 3, and 1, 2, 3. So if I have these points and I plot them, you should be able to see that that's going to be 1, 1, which is about right here, 2, 2, which is about right here, and 3, 3, which is about right here. Which means that this would have been a 1, this would have been a 2, this would have been a 3 on the x, and then on the y, 1, 2, and 3. Now, if I was given these points and I want to take this and create also, let me also include in here, no, I won't. I was going to include the origin, but I won't. So since I'm given these points, I want to follow these instructions and come up with and turn this into an even function. So I want to change the x values to negative x values. Okay, so these now become -1, -2, -3. And I want to keep the y values the same. And now I plot these points. So I have -1, -1, 1, which goes about right there, -2, 2, which goes about right there, and -3, 3, which goes about right there. And when I connect these, you can see that I have y-axis symmetry. What is on the left side of the y-axis matches what's on the right side of the y-axis. So if you followed these steps, it's pretty easy to create a function with y-axis symmetry. And it's easy to check because it either has y-axis symmetry or it doesn't.